Hey, what is this thing and what does it mean? Well, this is called a line integral or sometimes maybe a curve integral. And let's start with that letter C. It represents a curve. It could be in three-dimensional space. In this picture, it's in the plane. And imagine we're walking along that curve. What sort of questions could we ask? The simplest question I think we could ask is what's the length of that curve? And we could work it out here and we'd get that number just using some basic geometry like the Pythagorean theorem and length of the circumference of a circle. And that would actually be the value if we calculated this thing here. So this is called an integral of just the function 1 over that curve. So the simplest case, it's just measuring length. Now, what happens if we put something other than 1 in there? Well, it depends on the situation, but here's a good analogy. Imagine that as you're walking, there are just gold coins scattered around everywhere, and you're picking them up as you go along. One question I think you could ask is how much money would you have at the end? So for instance, if the distribution of those coins was such that you got $1 per foot that you walked, well, just knowing the length would tell us that we would have that much money. But what if there was a variable density, like in this heat map here? So what if some parts of your walk are more dense with coins and others were maybe sparser? Well, then what we would have to do is we'd have to add up the different densities along the path that we go along. And that's exactly what this line integral would do in this case. How do you calculate them? Well, there are some formulas. Here's one of them that you'll learn in a calculus class. But I think what's most important is this intrinsic meaning.